Hello and welcome everyone to the Combinatorics module, the second lecture of the Combinatorics module. So this might be repetitive for the content presented here. It might be repetitive for some of you, but it will be of help to others for sure. I'll also ask you to solve some and I'll guide you through them, right? Okay, but my only expectation will be that you are interactive with me and you answer questions through the chat or through the polls. But also, I must tell you something that you must hold on with me because towards the beginning there will be a bit more of theory rather than problems. Okay, but you will have a chance to interact. Right. Let's see an outline. So we will start with permutations and combinations. Uh, and then some combinatorial identities. We will look at the formula of them. The heart of today's course is counting the non-negative integer solutions for a given equation, and we'll look at inclusion-exclusion principle. Right. And of course, as it goes unsaid, there will be problems. Okay, so let's start with permutations. What do we want in permutations? We have done last day that if you have objects 1 through n, the number of ways to rearrange them in a line, say, is exactly n factorial. Now, what if you want to arrange exactly r of them? So, implicitly, it goes without saying that r is at most n. So, that is our question, that if you take r of them and want to arrange them, how many ways are there? Right? Okay. Now we just frame it in a different way. It is the same as asking what? So I will tell you that you have these n numbers and I give you n blanks, right? Uh, there are n blanks or dashes. You have to fill in the blanks. The options from which you can choose are 1 through n, these numbers, and you cannot choose anything twice. So no number will repeat itself. So that is a restatement of the problem we are asking. Okay, let's see how many ways we can do it. But before that, let me go through an example. Right. Okay, so what are the different ways? I give you 2 blanks and 3 objects, that is the numbers 1, 2, and 3. How many ways are there to fill these 2 blanks with these 3 objects? Can you give me something in the chat? Okay, somebody says 6. Aryan says 6. Abhinav says 3. Suman says 6. Some answers are 6, some more 6s. Right. Okay. Let's see. Let's see. Let's see. Instead of getting to the answer, let's see if we can list them down. So let's do it systematically. Okay. So what if the first position? Okay, I have 2 blanks, right? Let me fix the first position as 1. Then the second position can either be a 2 or it can be a 3. Okay. Can it be anything else? No. 1, 1 is not possible because I said that repetition is not allowed. Okay. Now 1 is done. So now what can be the other choice for the first blank? It can be 2, right? Now 2 can go along with 1, or it can have a 3 as its partner. It cannot have 2. Okay. Now similarly for 3, it is 3, 1 or 3, 2. So there are 6 of them. Okay. Someone says 3C2. Let's see, we'll come to that. What is it? So there are 6 of these. Our required answer is 6. So we now have the clear problem in our hand, that what we want. Okay. Now let's do it for general. So for the first blank, we have R blanks. Recall, we have R blanks and N numbers. For the first blank, how many of them can be there? How many options are there for the first blank? So what numbers can I put in the first blank? So yeah, 3 options. Over here, N options. If I take a look at the general thing, yes, in the previous, in our example, there were 3 options, namely 1, 2 and 3. In the general scenario, there are N options, 1 through N. Okay. Now, so I have taken away one number. So what I'll do is I will write it a bit differently. Okay, I will write N as N minus 1 minus 1. I'll tell you the reason why. Okay, so one number is taken away. How many options are there for the second blank? Right, N minus 1. Okay, yeah, 2 options in the example, but in the general scenario, it's N minus 1. Okay, so whatever number I have put in the first blank, in the second blank, I have every other number except this. Okay, I can put everything else. Okay, so I will write it a bit differently again. I'll write it as N minus 2 minus 1. Okay, right. Now, so we have all numbers except 2 of them, right? Now for the third blank, okay, we have N minus 2 numbers, as you all said. Third blank has N minus 2 numbers, right? Okay, again we'll write it a bit differently. Okay, and we continue like this, and then in the last one, that is the rth blank, how many options do I have? So for the first blank, it's N minus 1 minus 1. Second one, N minus 2 minus 1. Third one, N minus R minus 1. How many are there? N minus, I'm waiting for some answers. Okay, it's N minus R minus 1. So N minus bracket R minus 1, right? Okay, but we now still have N minus R numbers remaining in our hand, but there are no blanks. Okay, so we have done filling it. Now the above things, right, they are connected via what conjunction? And, or is it or? Is it and or is it or? So okay, I'm looking for some replies in the chat. Okay, yeah, nice. Okay, so some of you are saying that they are connected via and. If they are connected via and, okay, so a number of required ways is, since they are connected via and, we need to multiply these numbers. So we multiply n minus 1, so on till n minus r minus 1. Okay, now let's see. We could have gone all the way up to 1. So n minus, what we're seeing is n minus r minus 1, all the way up to 1. So we multiply that number. That is what? Just n minus r factorial. If we multiply in the numerator and denominator, in the numerator we have n through 1, and the denominator we have only the numbers n minus r to 1. Okay, so that makes it this formula. Okay, now notation is the thing. So npr, you can write p superscript n subscript r, you can write n subscript r, or you can write p of n comma r. All of these are good notations, right? So now let's get back to combination. So in combinations, what do we want? We want to just pick out objects. We don't want that we pick this first, second, third, fourth. We don't want any order. We just want to pick out objects anyhow. So you put your hands in a bag, pick out as many balls as you can, or pick out r balls out of the n bags, out of the n balls. Okay. And now the key here is that these objects are distinct, all right? Okay. But then order does not matter. Okay. So let's look at an example. What if I ask you to choose 2 objects out of 4 objects? How many ways are there? Can you comment your answers? Okay. All right. So someone has said, okay, so let me write this down, that this number, right, this number is denoted by like this, NCR, or it is also written NCR CR. It is also written C of N comma R. Okay, all of these are notations. Okay, so it is sure it is 4C2 by the notation only, it is 4C2. Okay, but what is the exact number? I'm asking in like give me a number from 1 to 100 or something like that. Okay, someone says 12, someone says 6. No, Rohan. Okay, someone says 4 into 3 by 2, which evaluates to 6. Someone says 6. Okay, the answer is actually 6. So let's see why it is 6. Why it is actually 6. So I can either take 1, 2. Okay, notice that I have written set 1, 2. So set 1, 2 is same as set 2, 1. Okay. So I divide the cases as what is the least number. So what are the sets where the least number is 1? It is either 1, 2, 1, 3 or 1, 4. Now what are the sets where the least number is 2? Okay. 2, 1 cannot happen. So we have counted 2, 1 before because 2 is not the least number in 2, 1. 2, 3 is possible, 2, 4 is possible. Nothing else. Okay. And if the least number is 3, it is only 3, 4, nothing else. Okay, so it is 6 of them. So this 6, we write that 4 choose 2. So we write 4 choose 2 is 6. Okay. Right, I will show you how to calculate this in a while. Before that, before calculating, before bringing in factorials, numbers, algebra, symbols, let us look at a combinatorial identity. That what is the power of this? Just the definition, like just normal English. What can you do with normal English? Okay. So I'm asking you, so this is true that if you choose n r objects from n objects, that is same as choosing n minus r objects from n objects. Okay. So how do I do the proof? Let's see. The proof is that we have to look at the same thing from various perspectives, right? I mean, sure, if you want R objects, okay, let's see if you want R objects. If you want R objects, cool, you pick the R objects in n choose R ways, okay? You have R objects, you are done, good. But it does not, it does not hurt. Okay, right, yeah. Okay, Rohan, people can see you on YouTube. Okay, it does not hurt to look at those objects which you don't want. You are looking at those R objects which you want, but you have to look. It's fine if you look at those objects which you don't want. Why would you look at those objects? So let's see. You first look at those objects which you don't want. You pick those objects. But why do you pick those objects? Because you want to throw them away so that you have R objects with you. Cool. But we have done the same task in different ways. So what do we have here? So both of them must be equal. Same task cannot be done in different ways, na? Okay. Right. If this is clear, I can move on. Can you give me some thumbs up or something so that I can get a message? Okay. Yep. Good. I have a nice audience. All right. Now we'll look at Pascal's identity. It is also a combinatorial identity, but it has a name, good name. So this is the identity. This is okay. This identity means that it is true for every n and every r, as long as r is this lower thing is less than the upper thing. Right. So how do we do this? Okay, yes, this identity is kind of like DP, but DP sessions will be held later. Okay, so left hand side, this one is straightforward what? Length subsets of 1 through n plus 1 picking r plus 1 length subset. That is, you want subsets which have length r plus 1 and you just pick them from this 1 through n plus 1. Okay, that is straightforward, just left hand side. Okay, now let us look at the special object 1. So this object, this guy. Okay, now the subsets which I am picking of r length r plus 1 or size r plus 1, those subsets can be divided into two parts, as in partitioned into two parts. One part is what? Either they contain 1 or the subsets do not contain 1. Okay, how many subsets contain 1? Okay, so this is the bucket, as in this is a subset. Okay, now I know that 1 is already present. 1 is already present. So I have these guys. From these guys, how many do I need more in this bucket? How many more do I need? I already have 1. I need a total of r plus 1. Okay, so I need how many of them? Can I get some comments? I need r of them. Okay, but from how many do I need r? From, okay, how many are these? These are exactly n objects, right? So is n choose. So choose n, r from n. Right. Now, if those subsets do not contain 1, so I'm saying that this 1 will not be here. I'm for sure this 1 is not here. I still have n objects, right? But I need to pick out r plus 1 of them. Okay. So this makes it n choose r plus 1. Okay. So what happens is, so for the first type, there are n choose r subsets which contain 1 for sure. Because if I'm putting 1 from 2 to n minus 1, from 2 to n plus 1, I have to pick out r. Okay, I put them there. And the second type, I know that 1 will not be there, but my feasible options are then 2 to n plus 1. There are n of them, but I still need r plus 1 of them for my subset. Okay, so there is n choose r plus 1. But these are connected via what conjunction? And or? Comments please. Okay, so a subset, okay, how can okay, so I'm saying that a subset can either contain a 1 or it cannot contain a 1. So is it connected via and or? Right, they are connected via the conjunction or. Okay, so we add them because they are connected via or, and it gives us this right hand side. But then left hand side and right hand side, we are doing the same task differently, right? We are just picking the subset which have length r plus 1. So their two must be equal. Okay, a third identity, again with English itself, no formulae. Okay, so this is okay, so let's I'm saying that m plus n choose r is equal to m choose 0 n choose r, m choose plus m choose 1 n choose r minus 1, all the way up to m choose r n choose 0. All right, so let me walk you through the proof of this. Okay, now I'm considering a situation when there are, so you have a class of students, there are m boys and n girls in the class, and we need to pick exactly r students for a trip. Maybe the school is taking for a trip. Okay, so the thing is, this is directly, you can see that this is done in m plus n choose r ways. Okay, because we just need students and there is no restriction. Now let's have another perspective that okay, so let's look at it gender wise. So what are the cases that we can have? Either we can have that there are 0 boys and r girls, there is 1 boy going and everyone rest is the girls. So the boys is 2 and the r minus 2 are girls, and it can so on continue till r boys and 0 girls. All right. Okay. Now how many, okay, so let's take this. How many possibilities are there for this? As in, how many ways can you choose two boys and r minus two girls? Two boys and r minus two girls. Can someone write in the chat? Just this. So, two boys to be chosen and r minus two girls to be chosen. So, someone has written, okay, so this is exactly this term. Okay. Let me just put an arrow. Right. Okay. Now this is what? This refers to this term. This entire thing. Because I'm choosing one boy and r minus one girls. And this last thing refers to this term. Okay. So I'm choosing r boys out of m and 0 girls. Right? So, okay, now I have the count for each case. I know how many of this, how many of this. How are these bullet points interrelated? Is it via and or is it via or? Okay, yeah, they are connected via or, because I cannot have any two of them simultaneously. I can have either this or this or this. So we just simply add them and it gives us this thing. But it's again the same thing done in a different way. So both of them are equal. Good. We are good with this. Okay. Yep. Maybe a thumbs up or something. All right. Okay. Yes. Now, so now we come to the formula. Okay. So if I'm taking all objects to be distinct, I won't mention it again and again. Okay. So to find a general formula for n choose r, we all know what is n choose r. Let me recall. Choosing r objects out of n objects. And when I say objects, distinct objects. Okay. So we reflect upon permutations. But why do we want to look at permutations? Because if you state the case of permutations exactly in English, so it's like R permutation, as in NPR, that thing. What is that? What does that mean in English? It means that you are choosing R objects from N objects and then rearranging them, right? So pick R objects and then rearrange. So I'm making a poll. So what do you think should be true? Should it be that number of ways to rearrange R out of n objects, is it same as, is it equal to, okay, don't type in your answers. I'll give a poll in a minute. So number of ways to choose R from n plus number of ways to rearrange those R objects, or is it number of ways to choose R from n and then multiply by the number of arrangements of these R objects? Okay. So what do you think? What should be the true thing? Should it be A or should it be B? I'm giving you a poll. Okay, so the poll is of 15 seconds. The poll starts now. Choose A or B only. There will be option C, D. Choose A or B. Okay, right. So all of you who have voted for the poll have chosen B. Okay. Yeah, so indeed it should be B because this is connected via this conjunction and. Right. So what do we have? We have this NPR equals to n choose r times r factorial from option B. So this is just option B, right? Because I have multiplied. Now we have already seen what is NPR. N factorial by, so we have seen what is NPR, n factorial by n minus r factorial. Just substitute and we get the formula for n choose r. Okay. So this is the formula for n choose r. All right. moving on. So what does that, I have divided so many times, what does this division mean? So intuitively, what does the division mean? Okay. So last day we saw this word that if there are repeated letters, then we take all the permutations, that is the length factorial divided by the factorial of each part. Okay. So what is m1 factorial? The rearrangements of this part. What is m2 factorial? Rearrangements of this part, and so on. Okay. So what this means is, basically for every permutation of W, when you regard these letters distinctly, okay, first regard these letters distinctly, then it will give you m factorial, that is the length factorial, if you regard distinctly. But we don't want them to be distinct, right? We want to discount those permutations, like we want to uncount them. So we want to uncount L1's permutations, L2's permutations, and so on. So L1 refers to m1 factorial into m2 factorial for L2 and so on till mk factorial. So we want to remove this number, but removal is subtraction, right? Not division. Okay? Doesn't that seem fishy? Okay. But here is the key that we are taking for every permutation. So for every permutation, we are removing this. Okay, for every permutation, we are removing this by Rohan, which means we are subtracting repeatedly. Okay, and what is repeated subtraction? So repeated subtraction is just division, just like repeated addition is multiplication. Okay, so for combinations also, if you have a particular rearrangement out of those n factorial guys, you take the first R, but then discount the permutations of those R objects. Okay, that is, you divide by R factorial. But you also have considered the arrangement of the last n minus R objects. So you discount that n minus R factorial of them. Okay, so that is why it is n factorial by R factorial into n minus R factorial. Okay, right. Even in permutations, you have to discount the permutations of the remaining n minus R of them. That is why it is n factorial by the remaining part, which is n minus R factorial. Okay. Now we change our topics. Okay. Now you have n balls and k sticks. All these sticks are indistinguishable. How many arrangements are there? Okay, sticks are indistinguishable. Like sticks look the same. The balls look the same. How many of them are there? Can I get some ideas as to what we should refer to for to solve this problem? Can I get some ideas in the comments, please? Okay, re-explain. So I have n balls and k sticks. I want to arrange them in a line. Okay, the balls are the same. The balls look the same. They are indistinguishable. The sticks look the same. They are indistinguishable. Okay, how many ways can I rearrange them? Okay, can I get some ideas or comments or whatever you want to say, anything in the comment sections? Okay, someone says k plus n factorial. Okay, but I said that you need to remove, you don't want to count the permutations of the balls and the sticks, because the balls are the same, the sticks are the same. Okay, I'm getting some interesting answers. Okay, let's see what we do. Okay, so what did I say earlier? You have this. Okay, let's see. So think of it as you can arrange all the sticks in k factorial ways, right? But what did I say? The sticks are same and the balls are the same. In that case, you need to discount. Okay, the permutations of the balls and the permutations of the sticks. So how many permutations of the balls you want to discount? N factorial, and you want to discount by k factorial. So you divide by n factorial, k factorial, and by the previous formula that we got, this is just n plus k, choose n, or you can also write it as n plus k, choose, both are same. Okay, because n choose r is n choose n minus. So this thing I can just in the bottom I can put minus the n, right? Okay. So what is another way to see this directly is that you have say n plus k blanks. Okay, so someone is asking me to explain using n equal to 2 and k equal to, let's see. Okay, it will be pretty big. So can I explain using n equal to 1 and 2? Okay, so I have one ball and I have two sticks. Okay, so these sticks are the same, this ball is the same. So how many arrangements can I have? This is one arrangement. Okay, this is one arrangement. And this is another arrangement. Did you understand what am I trying to say? So how many permutations of these balls and sticks are there where these balls are the same and the sticks are the same, but a ball and a stick is different? So if I go back to the last slide, okay, so you can think of L1 as the balls and L2 as the sticks, and there is no other letter, so this part is absent. So how many words are there? So that there are, this is n balls and there are k sticks. So you put it here, it is n plus k by k factorial n. Okay. All right. Okay. Now an alternate solution is that you have to think of filling up n plus k blanks. Okay. Now how do you fill this? So you first decide that, yeah, these are the places where I want to put my balls. So yeah, n blanks. These are my n plus k blanks over here. Okay. And these are the places, n places where I want to put my balls. Okay. Is that enough? Yeah, that is enough, right? Because if I put my balls over in those n places, what remains is k blanks. And I will just put my sticks over there, right? So if I just pick out n blanks for my balls, the sticks automatically sit in the other places. So it is just picking out n blanks, right? Just pick out n blanks. From how many? N plus k. So that is simply n plus k, choose n, right? Okay. All right. Okay. So which solution did you like more? The first one or the second one? Okay. So Bhaiya is one general. Okay, this part is sufficient for the combinatorics part of the ZIO, but you also need to combine it with recursion and DP and other number theory. Yeah, but what I have taught for permutation, combination, and repetition, permutation with repetitions, combinations, and this equation ka solution, this part is sufficient. Okay, right. So number of non-negative integer solution. A big jump, right? The previous one was balls and sticks, and now we come to number of non-negative integer solution. Something totally unrelated, but I'll relate it for you in a while. Okay. So let's see what I want. So this is an exercise for you that count the number of non-negative integer solutions to this x plus y equal to 5. So I want you to find me pairs x comma y, okay, where this x and y are non-negative integers and their sum is 5. So how many of them are there? Answers in your comments. Okay, so I said non-negative. Okay, so 0 is included. Um, some more answers. I would like some more answers. Okay, some of you have said 6, some have said 4, some have said C 6 comma 4. All right. So let us just, instead of looking at the answer first, let us just list them down. That's the easiest, right? Okay. X can be 0. If X is 0, what can Y be? Y has only one option. Y cannot do anything. If I go to X and tell, yeah, X, you are 0, nothing else. Y has to be 5. I can't do anything. Okay. I go to X and tell X, you are 1, nothing else. Y has nothing to do. Y has to be 4. Similarly, if X is 2, Y has to be 3. And then 3 comma 2, 4 1 and 5 0. Okay. Is there any other possibility? If X cannot be less than 0 because it's non-negative. If X is greater than 5, then what happens? Y will become negative. No, I cannot let Y to be negative. I have said here that Y has to be non-negative. So there is nothing other than this. So how many? 6 of them, right? Okay. So let us visualize what is happening. Okay, we will use this. Okay. So imagine there are two boxes. The first box contains X balls, the second box contains Y balls. Clearly, X and Y have to be non-negative. How can you have negative number of balls in any box? Okay. And now I want to put 5 balls in those boxes. Okay. So how can the boxes look like? So this is 0 balls in the first box and 5 in the second. Or I can have 1 in the first and 4 in the second. Or 2, 3, 3, 2, 4, 1 and 5, 0. Okay. So now can you see a relation that how is that equation related to putting balls in the boxes? So this corresponds to what? 0, 5. Right? Can I get some thumbs up if you have understood that how it is related, how they are related? Okay, yeah, this sounds good. Okay, they are related somehow. Okay, now what I will do is I will remove the unnecessary details. For example, why do I need this thing for? Why do I need this thing for? Okay, why do I need this top shelter? Okay, but this is necessary, right? This part is necessary. I want to differentiate between the two boxes. So I keep this. Okay. Now I remove unnecessary details. So I keep just the gap between the box. The gap I will write it as a stick. And that is, so here there are 0 balls. And here there are 5 balls in the other. Similarly the others. Okay. So I go on. So till now did you understand how that number of solutions, that algebra thing is related to this ball and box? Right. Okay. If I give you that algebra solution, it is same as making a problem with ball and box. And if I give you this ball and box configuration, you just count how many balls are there. Which one? Which slide do you want, Abhinav? Is it this? Okay. Moving on. Okay. Right. So from now on, non-negative integer solutions, we'll call this NNIS in short, so that we don't have to write again and again, right? So finding the number of non-negative integer solutions to this big equation. Over there are two variables. Now we have k variables, and instead of 5, we now have n. Okay. Now what can we think of this as? Putting n balls into k boxes. Over there we had 5 balls in 2 boxes. Over here, suppose you have k boxes. First box has x1 balls, second one has x2 balls, and so on. And total number of balls has to be n. Right? So, okay. Now the number of ways of putting this, like the number of configurations of n balls inside k boxes, that is same as the number of solutions of the above thing, as you have seen earlier. So this is because of that each solution. So if I have a solution here, non-negative integers which sum to n, that corresponds to a ball and box configuration, namely first box has x1 balls, second box has x2 balls, and dot 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 kth box has xk balls, and vice versa. By counting the balls, you get a solution of this algebraic equation. Okay. Now you remove the unnecessary details. So imagine the picture in your brain. Okay. Remove the top cover, bottom cover. Okay. All that is necessary is that gap between the two boxes, that partition. Okay, that stick. So you replace that with a stick. So how many sticks do we have? So the boxes are one after the other, right? Adjacent boxes in a line. So if we have 2 boxes, there is 1 stick. So 2 boxes, you separate them with 1 stick. If you have 3 boxes, you separate them with 2 sticks. If you have k boxes, how many sticks do you need to separate? Can I get some more comments? Okay, yeah, you need k minus 1. Yeah. Why is it root n into 2? So you need k minus 1. You need, if there are k boxes, you need exactly 1 less stick to separate the boxes, right? So because between 2 boxes you place 1 stick. Okay. So the problem reduces to finding the number of arrangements of k minus 1 sticks and n balls. Okay. Is this clear? Why? So just putting balls in boxes, I remove the unnecessary details. I just keep the sticks. I keep the sticks. So arranging those sticks is enough. Arranging the sticks with the balls is enough. So if you have understood so far, can I get a thumbs up? That just indicating that you are fine with this. Right, okay. So I think people are comfortable. In that case, I showed the answer, but okay. So that number is, we have seen. What was the number? That number was, so number of balls plus number of sticks, choose balls. Okay, this was the number of arranging, so balls plus sticks, choose balls. This is balls, this is sticks, choose balls. Okay, so this is the answer. So number of non-negative integer solutions to this equation is exactly this. All right, keep this in your head. Okay, this is very useful. Now let's walk through a problem. Okay, so let's walk through a problem. Okay, all right. So find the number of non-negative integer solutions to this equation. Okay. Now this part is fine with you, right? So till here it is fine with you. Till here you can do. But I'm giving you the additional thing that x1 will be at least 1, x2 will be at least 2, x3 will be at least 3, x4 will be at least 4. What can you do? Can you give me some ideas? What can you do? So think in terms of balls again. Balls inside boxes again. Where x1 is the number of balls in first box, x2 is the number of balls in second box, and so on. Okay, I have got a good idea from Aryan. Okay. Anybody in comments? What can your ideas be? Okay, yeah, okay, yes. Aryan Pahari has given a good. Rito Saha, I did not quite understand what you wanted to say. Okay. Seems like okay, yeah. I think I understand what you want to say. Okay, so the idea is that when you are starting with those boxes, you start with a configuration such that the first box already has one ball. The second box already has two balls. Okay, so Sriteja Reddy. Right. So we are not looking for answers. We are looking for procedures. Okay. So first box has one ball. Second box has two balls already. Okay. Now what do you want to do? So you subtract x. So you subtract 1 from x1. Okay. So you put 1 inside x1. What does that mean? You already make x1 minus 1 to be y1. You take y2 to be x2 minus 2. You take y3 to be x3 minus 3, y4 to be x4 minus 4. And now if we are looking for non-negative integer solutions to y1 plus y2 plus y3 plus y4 equals to 20, why 20? I just subtracted 1, 2, 3, 4. So in total I subtracted 10 from both sides. Okay. So this thing equal to 20. If you now look at putting extra balls in this y1, y2, y3, y4, that is same as starting with 1, 2, 3, 4 balls. Because we will add at least 0 balls, right, in the first box. So it will ensure at least 1 plus 0, that is at least 1 in the first. Similarly, at least 2 in the second. Okay. Now can someone try to tell me what is the exact answer? What will be the answer to this? So something, choose something. So A, C, B, something like that. A, then choose, and then B, something like that. Okay. So remember, it is balls plus sticks, choose balls. Okay, Sriteja, instead of N and K, can you put the values? Can you exactly put the values and tell me that something, choose something? Okay, I get some interesting answers. Okay. So how many balls are here? How many balls are here? Number of balls is? So if I translate this into balls and sticks problem, no, number of balls is 20 in this problem. In this problem, number of balls is 20. I want to put 20 balls in now, like the reduced problem in terms of y. Okay, number of balls in terms of y. Okay, y1 first box, y2 second box. Okay, so it is 20 balls. Okay, so 20 balls and how many sticks? 3 sticks. So balls plus sticks is 23 and number of balls is 20. So it is 23, choose 20, which is this, or you can also write 23, choose 3. Both are same. Okay. Is this problem clear to everyone? Maybe indicate with a thumbs up if you are comfortable. Okay, I can see some confused smileys. Okay, so Those who are confused, can you tell me a specific part which one to explain? If you are confused, can you tell me a specific part to explain? Okay, I will explain again. So initially you have these 4 boxes. Uh-huh. So initially you have 4 boxes. 1, 2, 3, and 4. Okay. What you do is you put 1 ball in the first box. You put 2 balls in the second box. 3 in the third. And 4 in the fourth. So if you had, let's see. So in this box, if you had a total of x1 balls, discounting this ball, how many more do you have? You have x1 minus 1, right? So if you discount this ball, you have x1 minus 1. Similarly, for the second, you have x2 minus 2 balls more, which I'm calling y2. So this extra part is y2. This extra part is y1. Why aren't we calculating the actual value? So do you want to calculate the value of 23? Choose 20. Okay, yeah. So my point was to show you how to solve problems. Okay, we can surely calculate the value, but in ZIO, you have to calculate the value in a calculator. Okay, so calculation is easy. It is 23, 22 to 21 by 3 into 2 into 1. Now you can use the calculator to find whatever this is. I don't know the actual answer. I did not calculate, but yeah, in ZIO you will have a calculator. Okay, right. So and if you remove 3, you have y3, and so same for this. So that is why I want y1, y2, y3 to be this. But if I want y1, so what the sum of y1, y2, y3 is equal to what? X1 plus x2 plus x2 plus x3 plus x4 minus 10. Sum of xi is 30, minus 10 is 20. So constraint to this and non-negative, yi and non-negative, how many can I have? Now is it clear for those who were confused? I hope it is clear. We will check it now. I will give you one exercise to do. Okay, this is one exercise. So I am asking you that find the number of positive integer solutions to this equation. Positive, okay, not non-negative. So x1 is at least 1, x2 is at least 1, x3 is at least 1. I'll give you the options. Okay, I'll give you a poll, and the poll will be a bit longer for you. Okay, so maybe 1 minute 15 seconds. Okay, yeah, 1 minute 15 seconds. Okay, maybe 1.5 minutes. I'll give you 90 seconds. No, maybe 1 minute 75 seconds. Okay, right. You can answer now. Maybe work this out and answer. 75 seconds. Okay, 60 seconds. There's a question. No, Ayush, others' comments are not visible to you. They will be visible only if you are a plus user on Unacademy. 30 seconds more. If you want to answer, you answer. And you should answer to check your concept. Okay, so we have a interesting answer here. So majority is B, 45%. Other A has 27% of the votes and C has 27%. And B has 45%. So this time majority is winning. So it's 36 answer. Let's see why. Why is it 36? Okay. So y1, so you fix yi equal, so y1 is x1 minus 1, y2 is x2 minus 1, y3 is x2 minus x3 minus 1. Okay. So you need to solve the need to find the number of non-negative integer solutions to the equation y1 plus y2 plus y3 equal to 7. Why 7? I am subtracting 3 from both sides. So 1 for this, and 1 for x3. So 1 for x1, 1 for x2 and 1 for x3. I'm taking away 1. That gives 7. Okay. How many of them are there? We have already seen that is 7 plus 3 minus 1 choose 3. So balls plus sticks. Choose sticks or choose balls. Same. Okay. So this is what? This is precisely 9 choose 2. What is 9 choose 2? 9 choose 2 is 9 into 8 by 4 by 2, sorry. So that is 36. All right. Okay. All right. Now we change topics again, but we will again we will need all of this inclusion, exclusion, and the previous one also. Okay. So what is inclusion, exclusion? So if you have two sets A and B, this A and this B, okay, what can you do? So what if I want to find how much material is there in this region? This part. Okay, so you must have done this in school. So I guess I hope so. That okay. So in order to do this part, find this shaded part, what you do is you take what is there in A. Okay, I'm shading this. Okay, you want parts from B also, you take what is there from B. But what have we done now? In doing this, we have taken this part 2 times. We don't want this 2 times. We want this one time only. Okay, we want this part 1 time only. So we subtract. So include A, include B. Okay, let me repeat. Include A, include B, exclude the repeated part, that is A intersection. So A plus B minus the same elements. Okay, so A intersection B. Yeah, Abhinav, you are right. The same elements in A and B. You have counted them once here, but you want to discount them once. You want them once only, not twice. Okay. For 3 elements also, you have this. Okay. So let's see what I am doing. You want the union in all 3. You want the union in all 3. Good thing. So you include A, you include B, you include C. But their intersections, but their overlaps. So this is A, this is B, this their overlaps. So this part overlaps. These overlaps have occurred many times. Let me draw it with a diagram maybe. So this is A, B, and maybe say this is C. Okay. I'm sorry for the untidiness, but okay. Yeah. So what do we want to do here? Right. So I'm including A, I'm including B, I'm including C. Right? Okay. So this part only, this part. I'm shading this part. This has been taken 2 times. This part has been taken 2 times. This part has been taken 2 times. I don't want 2 times. I want to subtract this, and this one. How do I subtract that, and that? So in my hand, I have this. So I cannot have just this part, right? In what I'm shading. I cannot have just this. I mean, I don't know what that is in terms of just A, B, and C. But I know this part, which contains the part which I want to remove. Okay. So let's remove this part only. So let's remove this part. And let's remove this part. And let's remove this part. Okay. But what have I done is, I have removed this so many times. So this part, this A intersection, B intersection, C, this part, I had once included it in A plus B plus C. So A contains it once, B has once, C has once. So total 3 times over here, over here, over here. But then I removed it 3 times when I removed this part. Okay. So I don't have this intersection part in this till here. Okay, that is why I need to include another this of this A intersection B intersection. Okay, so what I'm doing is include the single, guys. Exclude the overlapping, like the overlapping on 2 sets. Then I have excluded extra. Okay, here there was no extra excluding. I have excluded extra over here. So I need to include that what I have excluded extra. So you can try and continue and check what will this be if there are 4 finite sets A, B, C, and D. So what will it be? So it will be A till B till D. Okay. Okay, minus. So minus of this intersection of 2 sets. Okay. Plus this union. Okay, sorry, plus this intersection of 3 sets. Okay, when I say intersection of 3 sets, it means that so there are 2 things. So when I say intersection of 2 sets, I mean A intersection B, B intersection C, and C intersection A. So you take all possible 2 sets, take their intersection, and do this. So when I say all possible 3 sets, I mean A B C ka intersection, B C D intersection, A C D intersection, etc. And I need to finally exclude this A intersection B intersection C intersection D. Okay. So include single guys, exclude 2 guys at a time, include 3 guys at a time, exclude 4 guys. And even for n, it will go on. Okay. Now a different form. Oh. I'm sorry for this. I thought I had changed. Okay, now if we exchange the union. With the intersections. So if I, instead of union, I put intersection, and instead of intersection, I put union. Okay. The new formula will still remain true. Okay. The new formula will still remain true. And the easy way to see this is through De Morgan's laws. So which you might not know it via this name. You might know it via this, that the complement of union is intersection of the complements. Complement of intersection is the union of complements, and complement of complement is the set itself. Okay. So what you do is that you simply replace everything. E is complement of a set. Where you are given some superset, you are given some universal set, you take the complement of that. So it is basically that, I'll tell you what complement is. So you put complements here. Okay. So if you put complements in everything, you will get so unions will change to intersection and intersection will change to union. So that is one easy check. Okay. So what do I mean by complement is that if you have this big thing and you have this set X over here, this region is X. Okay, I'll shade. This region is X and this outside region is X complement. So when I say outside region, I need to know what is the universal set. Okay. Now that inclusion exclusion principle is very useful if you use it in this part. Okay, I'll show you an example right now. So let Xi be a finite set containing all of the AIs as I told you before. Okay. So Xi is this universal set. Now you use the above as something like this. So I'm looking at this guy as simply a set X. So the cardinality of X is just what? Whatever is present in the outside, not in the outside, whatever is present in the entire thing minus the outside part. Okay. So that is what I have written here. So this region is the entire region minus the outside part. Okay. That is simply what I have done in this equality. Okay. But now I apply De Morgan's laws to this. So union becomes intersection and the sets are individually made complements. So union becomes intersection and of union of individual complements. Okay. Now let me show you how to, and then what you do is you apply the what is that called, the IEP, that is inclusion exclusion principle, on this part. Okay, so if it is 3, if it is 2, so it will be Xi minus A intersection B. So A complement intersection B complement. But what is A complement intersection B complement cardinality? It is what? Just cardinality of A complement plus cardinality of B complement minus cardinality of A complement union B complement, and in everything inside bracket. Why did I put bracket? Because I want this minus. Okay, I'll show you a concrete example. So practice. So how many non-negative integer solutions are there? If I say that the sum is 15 with this, but there is, so till here you can solve, but with this additional restriction that I'm giving you this. I'm giving you the additional restriction that x1 is strictly less than 11, x2 is strictly less than 9. Okay. So let me define the sets. What I will do is I will separate the two conditions. So what I am asked to find is basically how many solutions are there where x1 is less than 11 and x2 is less than 9. So I will take a look at the following sets. So my universal set will be the set of all non-negative integer solutions. Okay, so let me first ask, is the problem statement clear to everyone? Yeah, subtract is complement. Yeah. Yes. Subtract is complement from number of solutions. Yes, but then we have to apply principle, that IEP again. Okay. So I will always say IEP from now on. Right. Okay. So let this be all the solutions without restriction. Let A be those solutions. Okay. let A be those solutions. So I will take two sets, A and B. One will have those solutions where x1 is less than 11. No restriction on x2. B will have those solutions where x2 is less than 9 and no restriction on x1. Okay. So x1 is those solutions where x1 is less than 11 and B is those solutions where x2 is less than 9. Okay. So what is the set being described here? So what is the set that is being described here in terms of A, B and Xi? Can you write it in the comments? What is the set that we're interested in? That is, we want the solutions, but x1 should be less than 11, x2 should be less than 9. So in terms of union, intersection, complement of A and B, can you tell me what is the set in the comments? Okay, so A, someone says A union B. Some more answers? Okay. Someone says A intersection B. Okay, maybe, okay, let's see. So I've got one answer union, one answer intersection. So it should be intersection. Why? I want to ensure that, so what does intersection mean? Intersection means that both of the events happen. Union means that either this happens or both happens. But intersection means what? Both of them happen. So this also happens and this also happens. That is why we need intersection. And we want to find the cardinality of. Okay. So now we use here what we want, what we had stated in the last slide. Okay. So A intersection B, cardinality of that is basically this. Okay. So it is A intersection B equal to, maybe I should make a step. So A intersection B is what it is. Maybe says Xi. My pen is not working properly. Xi minus, it is A intersection B whole complement. But this thing is only by De Morgan's law, A complement union B complement. Okay. Now what do we do? On this part, we apply inclusion exclusion principle. Okay. Does this make sense to everyone? You can react something maybe. Confused, okay. Okay, yeah, I'll wait for you. Confused, okay, thumbs up. So those who are confused, can you tell me exactly where you are confused? I may be able to clarify that better for you in that case, if you tell me exact part. Okay. Right, okay. So is there any confusion? Okay. So let's move on. We have this. Now these are just sets. Okay. What we will do now is we will find how much this is, we will find how much this is, we will find how much this is, and this is. We will find exact, and then we will do minus this plus this. Okay. Just simple addition, right? Okay. Cool. Okay. Now, so let's continue with this. Okay. So what is the set Xi? Can you tell me what is the set Xi? What is the set Xi? The set. All solutions, right? So the cardinality of xi is total how many solutions are there. Okay, how many of them are there? Okay, y16 it is balls plus sticks, choose balls. Okay, by the same argument it is 16. Okay, 15 and 2 minus 1 ball, 2 minus 1 sticks and 2 minus 1 balls. Okay, 2 minus 1 sticks again, sorry, 15 balls. Right. What is the set A complement? Describe the set A complement. In short, can you write in chat? In short, can you write in chat? Uh, what is the set A complement? Description of the set. Yeah, number of elements except A, but in terms of x1 and x2, what is that? So, yeah, in terms of x1 and x2, what is that? Okay, right. I'll tell you what this is. So, what was A? Uh, let's go back to the previous slide. A was all those solutions where x1 is less than 11 without restriction on x2. Okay. So, A complement is all those solutions where x1 is at least 11, again without restriction on x2. Right. So, how many integer, non-negative integer solutions are there? Can you tell me when x1 is less than 11 to this equation, this equation? Okay, let's see. It is what? How many are there? Okay, there are actually 5 because it reduces to 4, but yeah. Okay, I'm back. Right. Okay, so what? Okay, there are 0. So what is my final answer then? Uh, Anybody? So remember, what was it? Chi minus A complement minus B complement. Okay, plus this A complement intersect B complement. Okay, so what is my final answer? So it is 16 minus 5 minus 7 plus 0. So 16 minus 12. That is 4. Okay. Yeah. So now is this application clear? How do we apply principle of inclusion exclusion along with that fact that how much content is inside a set, that is complement of the outside. So entire thing minus the outside is that set. And in particular, is this example fine? Maybe give some reacts. Okay. Okay, let's move on. Right. So we will end today's session with a practice problem from ZIO 2020. Problem 1. Okay. So when I say find the integer coordinate, I mean that find the number of. Okay, find the number of. So find the number of integer coordinate points. So points a comma b where both are integers. A and b both are integers. Whose Manhattan distance, so it is a particular kind of distance from 0 comma 0 is at most s, and s will be supplied to you. S is an integer, okay. And what is the Manhattan distance between 2 points a b? You have points a b and xy, and that Manhattan distance is just difference between x and, so difference between x coordinate plus difference between y coordinate. So absolute value of x minus a plus absolute value of y minus b. Okay. So it's something like, so you have 0 0 and a point here. Okay. So how many steps do you, so something like this kind of distance. So Manhattan distance I have defined here. So you have this point and this point. The Manhattan distance between these 2 points is this line. Along this line, how much you have to travel. Okay, right. So maybe say something, if you have something like this, maybe how much you have to travel in this, along this line. Okay, so it is mod x minus a. So this part is mod of x minus a, and this part is mod of y minus b. Yeah, cool. Right, good enough. So let's see. What do we do now? Right. So, okay. So Aryan has given me a solution, but okay. So the answer is saying that it is at most s. Okay, it is at most s, not s. So first thing is that what s will be given to you. S will be given in the question. So I'm saying maybe say s is 5. How many are there whose Manhattan distance is 5, is at most 5 from the point 0, 0. Okay, so first thing you do is break the problem into smaller parts. How do we break it into? I am sorry again. Right. So what is it? Right. Okay. So it is, so call this AD, and my final answer would be how many points are there at a particular distance, and you sum based on the distances. So A0 plus A1 all the way up to AS. So the point at distance 0. So I'm talking about this guy. From the origin is just 0. So A0 is 1. Okay, is that cool? Okay, if A0 is 1. Now what if this distance is more than 0? Okay, let's look at some examples. So what are the points at distant 1? I will show you with a graph. So these are the points with distance 1. Maybe I will draw it with say green color. So these points that lie on this diamond, can you see the shading? Okay, so these are the points with distance 1. What are the points? This point, this point, this I will do this with red maybe. So this is the point 1 0. Okay, this is the point 0 1. This is minus 1 comma 0, and this is 0 comma minus. Okay. Now what are the points at distance 2? So these are the points. I'm showing this with and let's say a blue marker. Okay. So this is this. Oh, I'm sorry. Let me just erase everything first. Then maybe we can have a better picture. Okay. So what are the points at distance 2? Okay. Distance 2 points are, I'm marking with blue, huh? Hold on. Which one is the origin? Okay. So if this is the origin, okay, so I mark, so the point that I had marked earlier, this point, this point, this point, this, and this, these points are at a distance of 2. Okay. What are the points at a distance of 1? Those are not which I marked earlier. So 1 distance points are, I'll mark with red now. Okay. So it is just this point, which is 0 comma 1. Third point is minus 1 comma 0, and this point. Okay. 0 comma minus 1. Okay. Perhaps you are clear on this. Right. Okay. So what are the points at distance 3? I'll mark with a pink. Not a pink. Maybe I'll mark with a green. So points 3 points at distance 3 from the origin are this, and this, and then here, and this, and finally we are back. So I don't want to mark more because it makes a bit clumsy. Okay. So let us look at only this part. You can see that about the x-axis. So this is the x-axis. Let me just end. And this is the y-axis. Sorry, this is the x-axis and this is the y-axis. So you can see that around the coordinate axis, it is enough to look at only this. Okay. In fact, what we will do is we will not look at that. We will exclude these corner points. Okay. And we will look only from here to here. Only the inside part. We will not look at the corner. Why? Because I want to multiply by 4. So this part, let me make it with blue. So this part, interior part, this interior part, this interior part, and this interior part. Okay, here to here. They are the same. I will multiply by 4, but if I would include one of these corner points, I might have overcounted. So just for safety, I am counting only the interior points. Okay. So let's see how many interior points are there. So I want mod x minus 0 plus mod y minus 0 equal to d, which means mod x plus mod y is d. Okay, but due to symmetry, we will take only the x and y to be non-negative. Okay, so that makes it x plus y equal to d, because x and y are non-negative. We are taking only one quadrant, and then it is we can reflect that, and it is symmetric. So it's just 4 times. Now there are d plus 1 solutions. Okay, non-negative integer solutions to this equation is d plus 1. That is d plus 1 such points which lie in the first quadrant, including the x-axis and y-axis. So this includes the corner points d0 and 0d. Okay. So we keep these 2 points separately. This and this we keep separate. Okay. If we keep these 2 separate, what do we have? We have removed 2 points. We have d plus 1 point. So if you recall that segment, we had our axis as something like this, and the points were something like this, right? I continue till here. We are taking only these points. These are d minus 1 in number. So we are not taking this. We are not taking this. Okay. Cool with this. Now we just reflect it. So we have this part. We have this part. I'm not marking the corners. Check. Okay. So this is safely. I can do this safely. How many other points did I not include? I did not include this. I did not include this. I did not include this. And I did not include this. So these lines account for d minus 1 each. So 4 lines, 4 times d minus 1 and 4 points. Okay, so we have d minus 1 other point by symmetry, 4 times d minus 1. So these 4 lines total make up 4 times d minus 1. But we did not count these corner points, 4 of them. Okay, so 4 corner points. Just add these 4 corner points. We have 4d. So AD is 4D. What I mean is at distance D, exactly 4D points are there. Okay, whenever D is greater than 0. So we have our formula here. If you want to collect things together, you just sum, which is 1 plus this 4D from 1 to S. I take this 4 common out. So take this 4 common. It gives you 4 into this thing, whatever this is. Okay. So S into S plus by 2. And if you expand this, so cancellation, it gives you 2S square plus 2S. Okay, so if they give you the value S, just plug in to have your answer. And I have included this picture here. So how do you see 4? Because this part, the area of this part is half its height. Okay, half into base is okay. So base is how much? Base will be 1 less than the height or whatever it will be. Okay, base will be S units and height will be S plus 1 unit. So area, in other words, area of this region, the number of points contained in this region will be half into S plus 1. So something like that, area of triangle. Yeah, you can prove it by induction also. So this is one quadrant and you carry over this to other quadrants. So that makes it 4. This is a high level view. Okay. And then you also need to include this origin. So that accounts for 1. Okay. And this is just a high level explanation. Okay. And so for answer for S equal to 4 is just plug in here 4. Maybe 4 square is 16. Okay, so it's 2 into 4 into 5. What is into 4 into 5? So 2 into 4 into 5. That is 20 times 2, 40, 41. Okay. So I hope this explanation is clear. So this is just a high level view to look at this, that each quadrant has S into S plus 1 by 2 area. So till S, right? So this is the bounding region. So these are the points where it is exactly S, and this region is where it is less than s or less than equal to s, whatever. So let me mark it with a blue highlighter. Yeah. Okay. And 4 quadrants, so times 4, this 4, and 1 origin. Okay. So is this clear? Give me some reacts. Okay, maybe yeah. Any reacts? Maybe you can ask your questions, but okay, for today the session is over. So thanks for attending. I hope this helps. And there will be a problem set on Unacademy. So whatever I have taught you today, with a little bit of more maybe brainstorming, maybe a lot of brainstorming, you will be able to solve it. So you learned the formula for permutation combination, you learned how to use the combinatorial objects, and the heart of this is number of solutions. Okay. So ZIO cutoff for 2020 was, if I remember, for class 11 and 12, it was 80 out of 80. Are there any other questions, doubts, comments? Also, please fill the feedback form. Problem set will be released tonight at 8. So I will give my book recommendations in my third lecture. But for now, I will say practice art and craft of problem solving for problems. So it's a book called Art and Craft of Problem Solving by Paul Zeitz. Yes. So over there, you can look at the Combinatorics chapter where there are counting part of the Combinatorics, and maybe practice from there. Okay. Any doubts, comments? I will wait for a couple of minutes. Okay, so Simon has given. Okay, so do you have a question, Simon? Okay, no. So is it clear for you now? Okay, is there any website from which we can? There is no particular website, but there is a website called Art of Problem Solving. Over there, there are many communities where they practice problems, and I'm sorry, but you have to look out yourself on Art of Problem Solving, which community is fit for you for ZIO kind of like ZIO kind of problems. Because